In this tutorial, we will investigate the two types of planets, the terrestrial, which are Earth-like planets, and the Jovian, which are Jupiter-like planets. In our first example, we will compare the mass of these two types of planets using Jupiter and Earth. So we will compare the mass of Jupiter and Earth. The mass is a key property that distinguishes these two types of planets. So the mass of Earth is equal to 5.96 times 10 to the 24 kilograms, and the mass of Jupiter is much larger, 1.90 times 10 to the 27 kilograms. And what we're interested in is understanding how many times more massive Jupiter is than the Earth. So we'll form a ratio of the mass of Jupiter compared to the mass of the Earth and substitute the two values. So 1.9 times 10 to the 27 in the numerator and 5.96 times 10 to the 24 in the denominator. And you can put those values into your calculator and get that the ratio is approximately 318. And that tells us that the mass of Jupiter is 318 times the mass of the Earth. So one key distinguishing property between the two types of planets is the much larger mass of a Jovian planet compared to a terrestrial planet. So for our next example, now we're interested in understanding how to express the mass of one of the Jovian planets in terms of that most massive planet, Jupiter. So if we know that Uranus has a mass that's 14.5 times that of the Earth, then how many Jupiter masses does this correspond to? So how many times the mass of Jupiter? All right, so that's our question. And so from this, we know that the mass of Uranus, expressed as a ratio in Earth units, but we would like it in Jovian units, so it's 14.5 times the mass of the Earth. Now, by comparison, we'll use the result that we just calculated, that the mass of Jupiter is 318 times the mass of the Earth. So we can expect that the mass of Uranus will be a fraction of that compared to Jupiter. So now we'll form a new ratio of the mass of Uranus over the mass of Jupiter. And even though we don't have the exact values in kilograms, we have each of these planets expressed in Earth mass units. So we can go ahead now, and in our numerator we have 14.5 times the mass of the Earth. In the denominator we have 318 times the mass of the Earth. And you can see that the Earth masses will cancel. And then what we're left with is 14.5 divided by 318, which gives us 0.046. And that tells us that Uranus, the mass of Uranus would be 0.046 in Jupiter mass units. So while Uranus would be in one of these Jovian planets, it has a mass much lower than that of Jupiter.